So again, we have these surface area formulas now for our 3D shapes. So we've highlighted for the prism and the pyramid. We'll go into discussion on them a little bit more as we do problems. But here's the highlighting for the cylinder, cone, sphere, and hemisphere, and we'll discuss after you highlight along with me. All right, now that we've got it highlighted, and I'm going to leave it here if you're still trying to highlight along with me. There are some things for all of these formulas I do want to point out for you. I'm going to scroll back up for the top two formulas. You'll notice that in the formulas for both the prism and the pyramid, it uses what? What does big P stand for? Perimeter. So we will have to, as a small part of the problem, find the perimeter of the base shape. So we would find the perimeter of this rectangle, the perimeter of this triangle, the perimeter of this hexagon. And the surface area total, so lateral, I guess I should back up. Lateral surface area is talking about around the side of the shape, not including the two bases. So if I was doing the lateral surface area of this prism, it would be this side on the back, this side, and the side in the front, not the top and the bottom. We're talking about the lateral or side surface area. When it's just regular surface area, we're talking about the total as if you were wrapping the gift in wrapping paper, okay? That's for your prisms. You would need the perimeter of the base shape and potentially the area of the base shape. For your pyramid, same thing. It also uses big P, which we know is perimeter of the base, but it introduces this new letter. It is an L. Where is the L on the pyramids? How would you describe that? Like okay, love the use of the word lateral surface. On the lateral surface, I like to think of it as the length of the side. It's not a height because it's not going straight up and down, but it is like the length of the side. Is that what it actually stands for?
Slant height.
Slant height. There we go. Slant height is its actual name. I like to think of it as like the leaning side. All of those things start with L. That's pretty nice. If we look down at the cylinder, cone, sphere, and hemisphere formulas, though, you'll see that the cylinder is a lot like the prism, where we are going to find the perimeter and then multiply it by the height, but that's going to be 2 pi r since that's the circumference of the base instead of perimeter. We use a different word. And the same thing with the cone. We take the area, the perimeter, no, what is that? I am all over the place because my brain is not turned on. We have to multiply by the slant height again here on the side of the cone, okay? But we know how to use these formulas. We've shown me that we're pretty good at using the formulas. So let's go ahead and flip this over, and we're going to start doing the surface area and lateral surface area for composite shapes. If you look on back, our first question here wants me to find the lateral surface area. Lateral means all along the sides, not including the bases. So if we look at this image, I'm going to try to figure out how much wrapping paper it would take to go around the cylinder and around the cone, but not on the bottom of the cylinder, and like not the bottom of the cone because it's like stacked on top of the cylinder. Okay, so if I was writing this problem down like I had been writing the other problems for us today, or in this unit, we would find the lateral surface area of the entire shape by doing the lateral surface area of the cylinder plus the lateral surface area of the cone. Those are the two shapes that I would find the lateral surface area, and add them together to get the composite lateral surface area. So we do like we've done before. We flip it over, we find these formulas. So flip your paper over. Can you tell me the formula for lateral surface area of a cylinder? 2 pi r times h, yeah? And how about the lateral surface area of a cone? Pi r l. Now I'm going to write my L's as cursive L's because otherwise they look like ones to me. So that's what that symbol is. It is a cursive L. All we need to do is look at the image and find these things, these dimensions of our shape so we can plug it in. The 2 stays, the pi stays, but I can plug something in for r and something in for h on my first bit right here. For the r, that is the radius. What is the radius length here? 3. So we're going to put a 3 right there. And then we want the height. What is the height of the cylinder? 6. So we know we got to put a 6 right there. Okay, then we keep going. Then we're going to continue on. We're going to add the lateral surface area of the cone. Pi stays, but I need r again, and then I need l. We've already found R once. What was the radius of the shape? 3, which happens to be the radius of the cone as well. And then L stands for, I already forgot what it was officially called. Slant height. Wow. Slant height, which is the length here on the side, the slant of the cone, which is 5. So now that we have all of these things in here, we're going to turn to our calculator. Remember, I want you to show me the work by doing the first part up to the plus sign, the second part after the plus sign, then adding those numbers together. So if you would please put 2 times pi times 3 times 6 in your calculator, or go grab a calculator if you don't have one yet. Oh, look, and it's special delivery right for you. Thanks, Mr. Williams. Oh. We're going to round to 2 decimals or keep 2 decimals when we do these problems. So if I put that first bit into the calculator, 2 times pi times 3 times 6, I should get 113.10 when you round. And if I do the second part, pi times 3 times 5, what do we get? 12. Yeah, we're going to keep 2 decimals. Round to the nearest hundredth. So now to do the composite lateral surface area, we're, again, are just going to add those numbers together like it says. That'll be 160.22 centimeters. And then, ooh, what dimension do I give centimeters here if we're doing an area? Do I do squared or do I do cubed? Ooh, that was for volume because we did a 3-dimensional shape. Area goes back to just being squared. Yeah. Trick question there. So this is 160.22 centimeters squared. Anytime it's area, it's square. Anytime it's volume, that's when you cube the dimensions. So any major questions about this, how I'm doing these problems? Does it kind of follow what we've done before? I want to issue a little challenge for you. I want you guys to try number 2 on your own without me. I want you to find the total surface area of this composite shape. I'll give you a little bit of time to work, and we'll see what we can do. There are more than one way to properly work this problem. It just depends on how you see it. When I worked this problem, and this is one of the ways you could do it, don't erase what you've done if you are confident in your answer, because we might end up the same space. I see that there is a hemisphere, a cylinder, and then a hemisphere. And if I want the total surface area, I would do the surface area of all of those, except that the hemisphere and the cylinder share the same spot. So like I'm covered in the top and the bottom of these 2 shapes. So really what I did when I did this, for the surface area of this shape, I actually took the lateral surface area of the hemisphere because I don't want the base, and I added the lateral surface area of the cylinder because I don't want either of those bases. And then I added another lateral surface area of the other hemisphere. Yes, I know 2 hemispheres make a sphere. I'm just telling you this is one of the ways we could have done this. So if I turn to the formulas here to write down the formulas, the formula for a lateral surface area of a hemisphere is 2 pi r squared. The lateral surface area of a cylinder is 2 pi r times h. And the lateral surface area of a hemisphere, again, 2 pi r squared. Now we just need to find all of these values in the picture for ourselves to be able to use it. Okay, the 2 pi's drop down, and we'll start with the top hemisphere. What is the radius of the top hemisphere? 2. So I'm going to put a 2 right there. The 2 pi comes down, but then I need a number for r and a number for h for my cylinder. For the cylinder, what is the radius? Also 2. For the cylinder, what is the height? 4. Notice they gave us a straight up and down number for the height, even though that is a tilted cylinder. That is still a height. When you measure your height, you stand straight up and down, so a height should be measured straight up and down. Then we go to the other hemisphere. Again, what is the radius of the other hemisphere? It's still 2 because they're still the same sort of hemisphere, but I can highlight that. It's technically a different measurement. Okay, that's what I did. If you found something else to do this, again, don't erase your answer because you might end up at the same spot as me. When I solved each of these 3 little bits here, I got 25.13, and then I got 50.27, and then I got 25.13 again, which means altogether the total surface area of the shape should have been 100.53 inches squared. Were we close? Were we on the right track? Did we get it? Yay! So 100.53 inches squared. So interesting enough that when we said find the total surface area that we just found the lateral of the shape, it's because everything was a side. There was no tops or bottoms. Now number 3 we're going to do together because number 3 is kind of complicated. In number 3, can you talk to me? What shapes do you see in the composite figure for number 3? A pyramid. What else? And a prism. So here's the thing. This problem gets really hard if you use the orientation of the problem the way it is on your paper. So instead, what I want you to do is I want you to think about it as if it was shaped like this. Okay? Do we see how that's shaped? We're going to use this as the base of the shape, this as the top of the shape. I'm going to turn my paper back around, but I want you to know that I'm speaking about this side as the base. Let's see if I can get it straight up and down again without messing it up. Good, close enough. Okay. So if we look at this, to find the total surface area, we're going to find the surface area of the prism, except do we want both bases? We only want one of the bases because the other base is covered by the pyramid. So I'm gonna literally write minus one base. This will just help me out later. So I'm going to do the surface area of the prism minus one base. And then I'm going to add what? What other surface area do I need to find here? The pyramid. Do I want to find the total surface area or just the lateral surface area? Ooh, I heard both. Okay, so why would we only want the lateral surface area? Because the base is covered. The base is touching the other part of the shape, so we don't actually see this base in the composite figure itself on the outside for the area. So we're just going to do the lateral surface area of the pyramid. Well, those are all things that we can find on our formula chart. So flip your paper over, please. What is the formula for surface area of a prism? Should be big P times H, so perimeter times height, and then what? Plus 2B, and B is the area of the base. Now we did this before where instead of writing big B for area of the base, we actually looked at the base. What kind of shape is this base? A square, a rectangle, but it's specifically a square. The formula for area of a square was side squared. Okay, so the area of the base is side squared, big B. But instead of writing big B, we'll say what kind of area we're finding it's the side squared. Now we said that we're going to do the surface area of the prism minus one base. So instead of doubling the base, what should I change this number 2 into? Do we want 2 bases? How many bases do we want? Just one. So we're going to take that number 2 and we're going to change it into a number 1. Yes, multiplying by a 1 doesn't really do anything, but for our brains, that is doing the surface area minus one base. Because instead of 2 times the bases, we're just doing 1 times the base. And then we'll go to our lateral surface area of the pyramid. Can you guys read that formula for me? 1/2. You're looking at it. What does it say? Just lateral, because we don't want the base. But yes, you're looking right. 1/2 P times L, which is perimeter, times, wow, I cannot hang on to that word. Slant height. Slant height. Oh my gosh, I'm going to write that on my hand today. I don't know what it is. It's not even Monday. The leaning height. The slant height. Okay, so let's fill in some stuff we know. So for our base, which remember our base is this side right here. What is the perimeter of our base? If I was highlighting this the way it was highlighted on my notes, my perimeter would be this side. There's 3 of the, or that was 3 of those sides. I need 4 sides. 12. We got 12 by doing 3 plus 3 plus 3 plus 3. That's the perimeter of that side. So when I'm filling in my formula here, we're going to put a 12 right there. If you're like, what? How did we get 12? look, I'll show my work. 3 plus 3 plus 3 plus 3. That's the perimeter of that shape, right? Which is 12. So if you want to put a 12 there, that's fine. We're going to multiply it by the height of that prism. What is the height of that prism? 8, because again, we're thinking of this as the base, which makes this the height. Then we're going to add 1 times the side squared of the base. What is the length of one side of the base? 3. Now I only want one of those because we're not doubling the base. We don't want both. Then switching over to the pyramid, we're going to do 1/2 times the perimeter of the base of the pyramid times the slant height. Well, if I look at the pyramid, to find the perimeter of the base of the pyramid, what numbers am I adding together again? A bunch of 3s. You already know that's 12, but again, to show my work, because these are our notes, I'm going to show you how I did that. 3 plus 3 plus 3 plus 3. You could totally put 12 if you wanted. And then we need the slant height, or the leaning height. Look, I remembered it. The slant height, what is the slant height here? 5. I didn't highlight all of this stuff. The slant height is 5. Okay. Now it turns to a calculator. Again, the way you could put it in a calculator, you could put it all at once, but I want you to put up to the first big plus sign and then after the big plus sign together. So we'll put parentheses 3 plus 3 plus 3 plus 3, which is 12, I get it, times 8 plus 3 squared. That's only one of the bases instead of 2 bases. We'll put that number down and then we'll do the other part. For that first part, we did 12 times 8 plus 3 squared. What'd you get? 105. And for the next part, which is half of 12 times 5, 12 times 5 is 60. Half of that is 30. So our grand total surface area for the shape is 135 blank. What do I put after it? Inches squared. Very good. 135 inches squared. So the main gist of this is if you have a composite figure that I'm asking for surface area, make sure you don't accidentally add too many pieces. Honestly, look at it and see which sides of it you'd have to wrap with wrapping paper if you were wrapping a gift. That's surface area. Speaking of area and composite figures, today is the last day of your project. It needs to be turned in before you leave. Most of us at this point have our design looking pretty good. We are going to transition into doing the math. Well, look, we just practiced finding the area of composite figures. We were doing surface area of 3D figures, but you'll be doing surface or area of 2D figures in your project. So again, put these notes to the side. This content will be gone over again in the future, but the rest of today we're going to spend working on our project to getting it all ready to be turned in. Those of you who have finished your project, if you're missing anything else from me or for another teacher, that's what I want you to be working on. I'm nosy enough to check, so we're going to check, because I know you're done with my project, but we're going to check for other classes. We're going to check for other classes.